All right, so welcome everyone. Today's meetup topic is two different talks, but we are going to start with the basic of who we are. So just by the name, you can tell this is a community for people. It's basically working with data, and it is for data analysts, financial analysts, data scientists, software engineers, business professionals, or basically anyone who's interested in the data science world. And the main idea of these meetups is to have some practical, high-free talks on real-world data and AI. And the main methodology is kind of like learning together, networking, and sharing the experience from industry professionals or academia professionals from abroad and from the local communities as well. So yeah, that's the basic of who we are. I would also like to mention that we've had two previous meetups so far. One was about the data science and AI topics in the early stage of Amazon. It was a very interesting talk about the recommender systems that took in the early day Amazon, basically. Yeah, the second one was about the MCPs, which was and still is a very hot topic in the industry. Both of the talks are available on our YouTube channel. And I will share this presentation, by the way, so you can follow these links as well. So the first talk that we are going to have is about the media attention predictor. It is going to start very soon. After that, we are going to have a quick coffee break. Then we are going to have another talk that is the customer retention formula, that is about the machine learning driven discovery and A/B testing validation, and the speakers will talk about the rest. So I think we can already start our first talk. So Imola and Réka, thanks for joining us. And yeah, the stage is yours.
Thanks. Hi, everyone. It's really nice to meet you. Thank you for the invitation, and thanks for spending your Saturday afternoon with us. My name is Imola Horváth, and I'm the head of advanced analytics at Hi-Fly Labs. And with me today is Réka, Szabó, a data scientist on my team. And we are joining from Hungary, from Budapest. Our agenda is for today, give you a brief overview of the market we have been operating in, show you how our data science team and in general the data science profession has evolved over this turbulent period. After that, we will switch gear and introduce one of our projects from last year with the technical details. And finally, we will answer all of your questions in the Q&A session. So, Réka, could you please share our presentation? And at the beginning, just a couple of words about Hi-Fly Labs. So we are a mid-sized company with more than 20 plus years in the data and AI industry. As I mentioned, we headquartered in Budapest, Hungary. We deliver end-to-end AI solutions operating as a one-stop shop for AI and data, but not just in Hungary. We serve our clients across Europe and in the USA. Okay, and now let's go to the team evolution. And forward. Yeah, here we are. So our team and the data science profession have a long history. We started working with AI back then in the ancient time when it was still called data mining. We worked with Access and these legacy type of tools like SPSS or eViews. I don't know whether these names still means anything to you or not, you are not familiar with it. And back then, the expected output from a data scientist was only a notebook, a presentation with business recommendations. So then came the big data era, the first explosive era in the data science profession. And in this era, we solve mostly classical business modeling type of problems using machine learning models, especially in energy and retail sector. The most common topics were these churn modeling, demand and price forecasting, and we solved a lot of different optimization problems as well. And this was the stage where models became more powerful, data got larger, and the client started to expect measurable business impacts from data scientists and from this data science project. Then came the deep learning era. To keep up with the trends, our team started to gain expertise in natural language processing. We also did some slight experimentation with computer vision, but main focus remained on NLP and that where we built strengths. The most prominent project I want to sneak peek was with an American startup called Catilex. They were developing a contract lifecycle management tool, and we were the one who helped them enhance their software with different AI modules. And yeah, back then it was a very cumbersome and tough data science task to do topic modeling and summarization, sentence segmentation, or document classification. So it was not just type and do the prompting and the prompt engineering. It was really tough data science modeling problem using these BERT type of models and applying these different Python packages like Spacey and NLTK. But this seemed to be a very good foundation because at the end of 2022, when GPT was launched and this whole Gen AI hype just exploded, we cut very successfully this wave, and in 2023 we delivered a dozen of POCs. Mostly these were still these plain vanilla rag-based type of chatbots, and we had a very good conversion rate from POC to MVP above the industry average. And it was due to the fact that we very fast realized that Gen AI is absolutely not a miracle, and the good old data science cliche is still true that garbage in, garbage out. And we realized very fast that the real leverage is in document processing, grounding, evaluation, and choosing the right model for the right use case. And this Gen AI is not about hacking with APIs, as many software engineer things, no offense. So to sum it up, when I looked at how our team evolved and in general the profession has evolved over this very turbulent period, a few challenges really defined this journey. First, the technical bar kept rising. So you still need business orientation, but you also need much more engineering depth that at the beginning. Production ready code became absolutely non-negotiable. So I remember when I supervised younger data scientists and they were writing this spaghetti type of code across different notebooks. So it's a no-go anymore. And there was a shift from this notebook and delivering business insights to developing production-ready AI system which generate instant business value. So that's a big jump a data scientist have to face with. And these more complex AI systems are built in integrated teams, cooperating with business analysts, designers, software and data engineers. So it's not anymore just a one-man show of a data scientist. And now we arrived at today. The age of autonomous agentic systems. I want to share the current challenges and market outlooks from our perspective, and I want to emphasize that this is the perspective of a vendor company. So I think a bit different challenges occur in a software development company. But our main challenges, especially at client facing, that we are very angry of the foundation model providers because they set the expectations incredibly high with their fancy and very spectacular shows and demos. But the gap between those fancy demos and the features they show on these demos and the reality is extremely big. So still those tools which are very shiny and work properly and you can easily build an MVP or a POC, it's absolutely not an enterprise grade solution and it's absolutely failing at scaling. So when we put our solutions into production, we usually run into rate limit, latency, instability under real load. So yeah, it's quite cumbersome. And the other part, which is not acknowledged, that the production means integrating into real enterprise ecosystem, mostly with legacy systems. And it takes a lot of time, a lot of unexpected challenges. It's totally manual work. It cannot be automated. There are no standard solutions like MCP servers for these legacy systems. So it's a hidden iceberg, and it's hard to sell and explain the clients that why it takes so much time and money to put an AI solution which already work properly in MVP to production. Another thing which is really hard to explain to the clients that they really need to put effort into adoption. What I mean under this, that they need to devote time and money in UI UX designing, and after that in change management, because even a most state-of-the-art AI solution can fail in business environment and in business operation if it doesn't fit how people work. So in the end, they spend a lot of money on the development side, but the solutions won't be used if there's no proper UI UX designing and then change management. But I understand their point of view because they face a very strong ROI pressure within the company, and it's absolutely not trivial to get budget for this AI development anymore. You really have to prove it has ROI in advance. And the other pressure to the stakeholder coming from outside from the company, from the regulatory side, especially in light of the EU AI Act. So they have to put more emphasis on governance and security type of questions. And again, it's an extra add-on and extra time and money in project management and in AI development. We also feel pressure, not just from client side, but internally from a few directions. First of all, we need to shift from custom builds to blueprint-based delivery to be competitive with this low-code, no-code, and off-the-shelf products and type of solutions, especially when we are talking about chatbot-style use cases. And so when we are talking about clients and the sales phase and in the pre-sales phase, and when we are giving them proposals and price offers, they compare those ones with the offers of these off-the-shelf and low-code, no-code products. And yeah, it's hard to be competitive with those standardized solutions when you are doing something really tailored and customized for the client. And again, the role is evolving with the rise of coding agents. We are being pushed back again toward the non-technical direction. We feel the pressure that write less code manually and focus more on the technical consulting type of task. And yeah, as we already discussed, it's a very exploded era and the times we have living in, and the technology space just exploded, and it's extremely hard to keep up, try out everything, and remain state of the art. And within a vendor company, this R&D time is an idle time, so you have to limit it. And finally, just a couple of words about our project portfolio. So over these last 3 years, mostly, first of all, we are very proud of the number of projects we delivered over this short period. And we are also very proud of the diversity of this project portfolio, both across industry-wise. As you can see from the coloring, you can read the related legends of the color below the slide, and the diversity across use case wise, which is written on the boxes. And as you can observe, the level of autonomy of this solution evolved from the classical machine learning model problems and plain vanilla reg-based type chatbot to autonomous agentic systems, where our area solution not just solve a narrow business problem or answer to user questions, but rather trigger steps and automate workflows. And with respect to the production readiness represents on the epsilon axis, you can also observe that our solution progressed from PUC to MVP until the production phase, and now numerous our AI systems was integrated into the client's enterprise ecosystem. And already the hype was around generative AI over these last 3 years. Still, we delivered numerous classical machine learning type of projects, and is due to the fact that still many business needs which emerge at our clients can be solved with this simpler model, and you don't need that big LLM for this solution. So that's it in a nutshell. And for today's case study, we selected a special hybrid use case from the media sector. That's the article performance highlighted on the left corner of the present on the slide. And this one is very special because this was one of our most methodology heavy projects. But no worries, Réka will walk you through it in detail. And with that, I will hand it over to you, Réka.
Thank you, Imola. All right, so let's deep dive into the project. First of all, I'm going to give you a project overview to better understand our project. So what was our business problem here? First of all, our client was one of Hungary's leading media companies called Central Media, which has a diverse online and magazine portfolio. As our project scope, we had their largest news portal within the group, which has many articles around business, politics, lifestyle, and entertainment. And their pain point that we tried to solve during this project was that as they are a free platform, as many media customers, they are facing, they are really relying on the ad revenue. and they were facing a downturn in ad revenue in the past few years. And
yeah, I think we were cut off there from Réka.
Maybe till then, she resolved this technical issue. Is there any question regarding the first part of the presentation?
Yeah. So,
sorry, I have network issues. Can you hear me now?
Yes, we can.
All right, thank you. I'm sorry. Okay, then I'm going to continue. Sorry, what was the last thing you heard from me?
Yeah, the last one was about the dependence of the ad revenues from these media channel, and after that it was cut off.
Okay, all right, sorry, then I'm going to continue from the pain point. All right, so our client's pain point was the editorial time, as you can see, because it's the most expensive resource, and they were sought after a solution to stop investing to articles that weren't driving any value to the company. And our business proposal for this problem was a solution for identifying or predicting article success factors. I'm going to talk to you about this a bit more later. And also our aim was to develop the first version of the solution in a framework of a proof of concept project. All right, during this presentation, I'm going to talk to you about, first of all, the technical deep dive. Then I'm going to show you some model results. I'm going to talk to you about some insights we gathered during the project. Then I'm going to make some conclusions and talk to you about the next steps of the project. And then we will have a Q&A session at the end. So let's take a technical deep dive first. So first of all, when you are designing a machine learning pipeline, one of the most important things is to select a good target variable. For this, we had two very good variables. One was called page view, which is measuring how many people clicked on the article and opened it. And we also had read-throughs, which signals if a reader reached the end of the article or not. The problem with these variables were that page views not only signals the interest in the article, but it can also signal clickbait articles, and also the read-through rate. The read-through can also signal the page view. So it's really rely on page view also. So to avoid measuring clickbaitness, we decided to create a ratio out of these variables called read-through rate, which really measures the article quality instead of clickbaitness. And also to make it easier to interpret for our client, we bind it into classical categories too. We did a low, a medium, a high, and a very high class. These were 4 equally sized bins, but was chosen by the client's preference. Therefore, we could also evaluate our model regression based with an R-squared and the mean absolute error metric, and also by using accuracy. Okay, so the next step when you are designing a machine learning pipeline is the feature engineering, which was one of the most important phases of this project. We had almost 2 years of article data from the selected media platform. Therefore, we could get really creative on the feature engineering part. Therefore, we had many variables. We created more than 36,000 variables during this project, and we decided to create 12 feature groups.
Sorry, can we pause this for a second? I lost the connection to the meeting, so I will come back in about 5 minutes.
Okay. All right. Okay, so as I mentioned, we had many variables during this project. There were more than 36,000 variables. So we created 12 feature groups to better understand which characteristics influence the visual rate the most during the modeling phase. So let's get into our feature groups and understand them a little bit better. First of all, we created a context-based feature group, which was describing the placement context or type of an article. What do I mean by that? For example, we had many flags for our like characteristics of the article. For example, we had an F1 binary flag signaling if the article was highlighted on the main page of the media platform. And we also had a temporal feature group, which tried to capture the performance of previous articles. For example, we had variables describing the time since the last article of the author of the article, and also performance of previous articles in the category. Also, we had time-based features that indicated temporalities. For example, binary flags for is it a weekend, is it holiday, or just the publisher of the publication. We also had text-based features that describe the title and the body of the articles. What I mean by that, for example, we had title length, which is the character count of the title, also negative word counts, and a readability index describing the readability of the body of the article. Moving on, we had feature tag-based features. First of all, feature tags were basically keywords assigned to an article by the author. So there were like 5 or 6 feature tags for each article in our data set. And we created many features based on these feature tags. For example, how many feature tags are on an article, and also we created a diversity score, which describes how diverse are the feature tags on the article, or with other words, it really measured how often these feature tags co-occur together. And also we had LLM tag-based features. LLM tags were really similar to feature tags. The only difference was that we created these LLM tags with an LLM, and we created features based on these LLM tags. So these features also try to capture the performance of previous articles based on the LLM tags. For example, we had an average median read for the last 3 articles of LLM tags, which really signaled as trends of previous articles. All right, so we also created embeddings during this project, and we treated them as features. We created these vector representations of the title and the body parts of an article. And we had many new features based on embeddings. For example, from the body embeddings, we had 1,028 new columns representing a vector from an embedding. We also had encoded categories where we basically just created a feature for each category that were only also assigned by the authors of the article. For example, there was a sport one-hot encoded category, which was a binary flag signaling if it was a sport article or not. And there were many more one-hot encoded feature groups. For example, we created one for the authors, also for the feature tags and the LLM tags, which I mentioned on the last slide. And also we created a feature group for the target variable, which, as you can see, was our read-through rate in the 2 days that was measured from the moment of publishing to the next 2 days. All right, so what's the next step? The next step was to create a strategy for our methodology. And for that, we chose a rolling prediction with a live GBM model. First of all, we chose the live GBM model because we found that this is the state-of-the-art framework for many regression problems that is famous from its robustness and efficiency of handling large and complex data sets. And the other technique we used here was the rolling prediction. As you can see from the figure, you can see that we chose the A version when we created a training set of 2 years and then only predicted for the following day. And then we did our evaluation. And our test period was July 2024. So we basically did this whole process for 1 month's worth of test set. And why did we choose this rolling prediction? Initially, we decided to split the data randomly because we wanted to mitigate temporal bias and ensure the exposure to all recent trends. But we found out that we have information leakage because our performance metric was near 100%, which is crazy if you think about that. It is only a proof of concept project. So after finding evidence of the information leakage, we switched to a temporal splitting, which guaranteed that we have leakage-free models and an honest evaluation. And I talked about evaluation in previous slides, so let's deep dive into that too. In this project, we had both a regression and a classification-based evaluation because we wanted to enhance robustness. First of all, we had regression-based evaluation metrics like R-squared and mean absolute error for continuous outcomes. And we also had classification-based metrics like accuracy, precision per mean, and recall per mean to evaluate the model in a classification-based way too. And just a quick shout out to MLflow, because we use this free and open source software during our project, and I'm sure that many of you already use it. But if you're not, I think it's an excellent interface for post-analysis. And what was really a big advantage for us during this project, that all technical context information is saved for inferencing later. And we had so many experiments during this project that it was a really good tracker of our model performances. All right, and now I'm going to show you some other results and give you some insights from this project. First of all, our best model, as you can see in a regression-based, we reached a mean absolute error of 7.6%, which is, I think, a really great result as we had a proof of concept project. And you can see that when the true read-through rate is lower, then the model can a bit overpredict, but when it's higher, then the model can sometimes underpredict. So in the future, when they want to have a better model, maybe that's a good sign to get starting, develop the model more. And also, we evaluated our model with a confusion matrix and examined top-level metrics. And as you can see, it's a really good sign that the vast majority of the articles are concentrated around the diagonal. And also, we have pretty good precisions and recalls. The only exception is the very high true label group, where we have a really low recall, but that is something that can be worked on in the future. And also the accuracy was 53%, which is really strong result because we had a 4-label evaluation. And also what I didn't talk about in the regression-based evaluation is the R-squared. We had a 0.574 R-squared at the end, which is also pretty great. And also I wanted to talk to you about that most of the projects has a decision point where you have to decide if you want to have a better recall or better precision. And we also talked to our client about this. And we found that recall is more important in case of this client because just think about that. If we have higher recall and an editor want to get a prediction if an article will be successful and he or she can have more time on the article because it will be successful or not. If the recall is low, then maybe they will kill articles that would be more profitable before they are even written. So recall is more important in this case. All right, so let's talk about our best features. We created a shape pair plot to select our 25 most important features. For that, we use the shape library, which is an explainable AI tool. I'm sure you heard about it before. For that, we use this bar plot, and we found that the most important features are the features describing the body text and not the published date-based features, which would indicate information leakage. So we were really happy about this result. And also temporal features are really strong, and cosine similarity between the title and the body feature can also signal clickbaitness, which I wanted to show you that it took place on the 5th place in the top 25 features. So just if you look at in the top 5 features, there is a body paragraph count, a feature tag diversity score, which I talked about before, the title length, an average read-through rate in the past 2 days, signaling reading trends, and this cosine similarity between the title and the body, which was especially created to signal clickbaitness that our client really wanted to avoid in the feature. We also built different models on different feature groups to better understand what kind of features bring the most information to the model. And we found that our top 3 feature groups are the text-based features, then the title and the body embeddings, and then temporal features were also pretty strong. And what I want to talk to you about a bit more are the LLM-based tags compared to the feature tag-based features. It was also a really important part of the project because we wanted to check if LLM tags can perform just as good as feature tags. And we found that results were pretty similar to each other. So our model said that LLM tags show as much information as the feature tags, but no improvement compared to these handpicked keywords. So we concluded that feature tags can be replaced by LLM tags if our client want to save some time with that in the editorial phase, but the feature tags are just as good as LLM tags. So the authors are really good at assigning these keywords. Okay, so we also did a quick analysis on the confusion matrix errors, especially on the really big confusion matrix errors, which were miscalculated by 2 or 3 bins. So if we want to improve the model in the future, these are the points that we should start to improve on. First of all, we found that special article formats like paywall, live feed, gallery, which aren't marked in any feature during the modeling phase, because we didn't have information about this, were really erroneous predictions. Also, we found that many articles had hype topics. For example, in the selected test months, there were Olympics held, and it was a really hot topic. So this feature tag was marked with a really high performance in terms of read-through rate. But as you can think about it, many sports won't attract that much attention, and there will be hype sports too, not just the so not just the Olympics itself won't attract that much attention. We also found that negative topics such as the fuel price increase can also be a bit erroneous. We think that it's because it's a bit unpredictable if readers will get overwhelmed by negative topics, and maybe they tend to close negative articles before they finished it. So it was also a bit complex for our model. And also there were articles with unpredictable fresh topics which had no trends and no pre-existing feature tags linked to it. And also the placement of image, posts and videos were also really important for the model. And this was also a bit unpredictable for the model because we had no feature signaling the placement of these media embeddings. I just wanted to show you quickly how these special articles degraded the performance of the model. There were 2 days at the end of July where the Summer Olympics started, and these short articles really degraded the performance of the model, as you can see. We also checked the robustness over time, which was also really important for our client. For that, we were training a model from January 22 and June 2024. And then we predicted for data from July to December 2024 and evaluated it on a weekly basis. And as you can see from the plot, the results show that our model is pretty robust because the accuracy is slowly decreasing over time. And also, we concluded that the model shows that the constructed features are strongly influence the read-through rate, and we did not just capture the trend in the 2024 July period, which was our test month during the experimental phase. All right, and I wanted to show you some insights. I only selected a few, but for our client, we gave a really long list of these insights that were extracted from a shape summary plot. And these are like keys to write a successful article based on our model. So, for example, we found that title length is really important because shorter titles are linked to higher read-through rates. So maybe longer titles may give away too much information, allowing readers to understand the article's whole content without reading through the whole article. And I'm going to just choose another one because we have a little time left. For example, the numbers in the body. We found that articles with fewer numbers tend to have high read-through rates, which can also signal that these are short articles, which are easier to read through, or maybe because these articles can be more dense and complex with many numbers, and it's making more harder for readers to process, while articles with less numbers are typically more loose and easier to understand for a reader, and they don't get overwhelmed. And I wanted to show you that it's not a really good practice, but our client also wanted us to attempt to capture the meaning of the most significant embeddings, and we tried to do that. So it was because in the top 25 features, we found many embeddings. And this embedding I chose was also in the top 25. And we try to understand this embedding by selecting the top 10 lowest and highest values and examining the topic. And we found that on the lowest, we had all-time historical articles, and on the higher values, we had recent news, mostly about Hungarian currency. And we found that all-time historical articles receive higher read-through rates typically than these recent news. And our theory was that maybe those who open these historical articles are really interested in the topic and they will read the entire article. But on the other hand, many people who are just try to glance at recent news and quickly extract as much information as they can, maybe they are just looking at an article and then closing it without reading it through. All right, so at the beginning, I talked to you about the project goals. So first of all, our solution was to identify or predict article success factors based on our available data and to develop the first version of our solution in our proof of concept project. And that's exactly what we did. As you can see, our model was pretty capable of predicting attention based on our client's data and our features. And we proved that the success factors can be identified and also gain many insights to our client. And just to have a conclusion, what did this POC project really prove and what can be the future steps for our client? We showed many ways for them to try to use AI in the future in the editorial phase. And they today use it as a review tool for editors. As you can see, they can get automated reviews in editorial, legal, and compliance based topics. But there are also many ways how they can use the model and how they can use AI more at the heart of the editorial process. All right, and thank you for your attention. If you have any questions, we are happy to answer.
Thank you very much for the very interesting talk. And yeah, we have some questions from the audience. Yeah, I think it should be okay to use this mic. So
Sorry.
Yeah, you can just talk.
Thank you for the. Can you hear me?
Yes, yes.
Yeah, thank you for the presentation. It was very interesting, especially about the details of the implementation and the future features that you generated. So I have this question, maybe not related to technical side, but you mentioned that you had the LLM text, and you also like measure the user engagement somehow, like click-through rates, etc. So do you like have a AI, like data privacy and AI ethics incorporated in your pipelines, since you're working with the user data as well as sending the text to the LLMs, as I could understand that. So.
Mm-hmm. Okay, so during this project, we worked really closely with our clients. So the LLM tags were created by one of our clients' data scientists. So as far as I remember correctly, they used the GPT-4o mini model, and they I think they used a prescription for that. So I think they solved this problem, but yes, we didn't handle this. It was on the client. I hope this answers your question.
Yeah. Thank you.
Any other questions from the audience?
Maybe I have.
Yeah, sure.
Yeah, thank you so much for the lecture. I just wanted to ask, you provide a free batch of features, right? And this whole feature you put to IGBM model, right? Or you use this batch. For example, I'm curious about the embedding text. So you put in the embedding text in the IGBM model, and with another one, for example, time series features or one hot encoding feature, yes, or I misunderstand.
Mm-hmm. Okay, so at the best model, we used all our feature groups together. And you especially asked about the embeddings. So we created, so we exploded our embedding vectors into separate columns, and we also gave that as variables to our model. So just to answer your question, yes, we used all our feature groups for our best model. We only experimented on training separate models on separate feature groups just to gather more insights for our client.
Got it. Thank you. It's very curious approach. Can I ask another one question about time feature engineering? Do you use some normalize for time feature, for example, make stationarity or normalize somehow, or how do you process this?
Sorry, I couldn't really hear you. Can you please?
Yeah, it was about the time series processing steps, like whether you do any normalization steps or stationarity removal tests or some kind of processing like this. Am I right?
Yeah. Thank you.
Okay, thank you. No, we didn't handle any time series based problems like stationary and stuff. We only created a PLC model, so if the client wants to use it in the future, of course, it is advised to use. But for this project, we only created the first version, which was a simple IGBM, only relying on the features and parameters that were optimized by a grid search CV.
Thank you so much. Thank you.
Thank you. Any other questions? Yeah.
This was quite interesting, especially the model, and I was interested in explaining the AI because I did so much it and learned. So I'm interested in most of the time the model has quite no linear relationship between variables. Have you tried to model the interaction between different features? Like as I remember, it's partial dependence plots in sharp. Because it can capture non-linear relationship between variables and maybe distort insights most of the time.
All right, I couldn't hear it either, sorry. Can I ask for your help?
Yeah, so it was about the non-linearity feature or family of basically these features. And how do you handle nonlinear relationships in your models? It was kind
interactions between different variables.
Yeah, interactions between the different variables, yeah.
To try to explain different interactions between variables.
Yeah. If you try to explain different interactions between the variables.
Because most of the time, if we don't check such interaction, it can distort the insights about of symbols.
All right. So we didn't really handle that during this project, but we didn't found any evidence that it was a problem during our modeling phase. But so we created many model versions and try to understand the effect of variables with sharp summary plots. So of course, I'm really pretty sure that there were some connections between the variables and they were affecting each other pretty much. But I think that the light GPM model is pretty intelligent and it can handle these complexities. I hope that that's a good answer for your question.
Thank you.
Thanks.
All right, any other questions? So yeah, we don't have any other questions from the audience. So thank you very much for your presentation. It was really nice meeting you and your understanding your projects a bit more into the technical details and from the business side perspective as well. So yeah, thank you very much and hope to stay in contact.
Yes, for sure. Thank you again for the invitation. Have a nice rest of the day.
Yes, thank you. Have a nice evening.
You too.